Hi, y'all. Mary Esther here. We have Tiffany with us, and we have Sarah Abraham, who is one of our lecturers in the Department of Computer Science. Sarah, we'd love to hear about what you do for the CS department and why you love it.
Well, hey everyone. I'm a lecturer in computer science. My area is games and graphics. So I work with students in graphics, which I'll probably talk more about in a moment, as well as game development, which is I don't teach design or art. I teach the programming side, how game engines work. So if you've used Unity or Unreal, how are those engines made? And then how do you build games on top of them?
Tell us a little bit about your background, how you got to where you are, what's your education path?
So I had a actually kind of non-traditional education path. I actually ended up doing my PhD at UT Austin. So I've been in this department a very long time. But before that, I was in a liberal arts program at Wellesley College up in Boston area. Because I really didn't have a plan. I didn't plan on going into CS. That really wasn't even on my radar at the time. I was going into marine biology was what I thought I wanted to do. But it turns out I didn't really like taking biology classes. And a friend of mine was like, well, check out CS. So I took a CS class and then I really, really liked it. And kind of in parallel to that, this is going to be sort of the typical, I guess, gamer story. I liked video games my whole life, and I was very interested in them. And then I sort of, taking CS classes made me sort of think, oh, that's how games are made. This is the process. So I got really interested in games and actually art. So I have a sort of mixed computer science art background. Um, and then when it came time to sort of think about grad school, I realized I didn't really want to focus so much on the art anymore. I wanted to go more sort of fully into the computer graphics side of things, and sort of really understand the math and the physics behind those. So that's why I decided to focus on that for my PhD.
You took a lot of math courses along the way.
Surprisingly few actually. I actually would argue graphics is the best way to learn about like linear algebra and other sort of math related to that. In a weird way, because obviously I had my undergrad, and I took what was necessary for grad school, but a lot of the math and physics it's what you would learn in another class, but it's very applied when you apply it in graphics. You kind of see exactly what's happening under the hood. Oh, I was gonna say, for better or for worse, I will generally teach the math more as an applied thing rather than trying to use the mathematical terms, unless the mathematical terms are necessary. They're both important, but I think especially CS students sometimes prefer to avoid math more than say maybe mechanical engineering students. But I think we are just as capable of doing math as them, and we should embrace it as much as possible.
What courses are you teaching at UT?
So this coming semester I'm actually going to be teaching a new class. So I'm teaching a class I've taught, which is called Game Technology. That's engine building. How do I make a game engine? And then I'm teaching a new class called Game Programming Paradigms, which is uh, kind of similar. It's still going to be talking about engine development, but we're going to be working in Unreal, and looking at the decisions Team Epic made while building their game engine. So how did they build out networking? How are they thinking about AI? How are they thinking about designers and artists using their software? So we're going to be looking kind of more at a commercial application on a large scale development. And this class will also, I think, be really interesting to students because you're going to be working in teams and you're going to be sort of actually building out on commercial software, which is something that you often don't get unless you do an internship. So I think it's going to be really exciting for students.
Oh, that sounds amazing. Is this a concept that you came up with and like proposed and then implemented? How did it come to being?
Yes, I did all of those things. So all of my personal development is in Unreal for the most part. I do a little mobile development on the side as well, but I work a lot in Unreal Engine. Every engine has its good and its bad sides, but one of the things I sort of noticed is that transitioning from sort of working in school to working in industry and sort of working on these large systems can be very difficult for students who don't have firsthand experience. So I thought this would be kind of an interesting way to combine my personal enjoyment of working in Unreal and showing students how to kind of work on it, how to learn a system that is massive, like probably the most massive software system you've ever worked with. Um, and how do you learn to use that system, and how do you learn to work on teams on that system? And so these are all things I thought would be fun for me and fun for students.
There's 24 hours in my day. How many hours are in your day that allow you to create new classes, run a company, well, teach different classes each semester and run a company? Can you tell us a little bit about your company?
Oh, so yeah, in addition to all of this, I actually do like making my own games. So I still really enjoy my personal development. Um, I'm actually working on two projects. One's a little personal mobile project, and one's kind of a longer project that I've been picking at, and I have some new ideas. It's always like it's because it's just me. It takes a while. It's very iterative, and that's sort of my pet project, though, is sort of understanding how people collaborate and cooperate through games. So it's a basically a cooperative game that's built around trying to understand empathy. So there's a little bit of psychology component in it, and it's been kind of interesting because I've had the great part about being at UT is I've gotten to work with some actual psychologists, sort of discussing these ideas and understanding what I'm doing right and where I can potentially improve as well.
Another one class that you and Dr. Norman have started and created is the ethics course. Can you tell us a little bit about why it's important to offer an ethics course to computer science students?
Oh, I mean, I would argue every student should take an ethics class, but perhaps CS students need ethics the most because we're going to be dealing with so many more potential ethics challenges than a lot of people. Um, especially for students coming in, one, it's going to be just like working in computer science. What does it mean to cheat? How do we know when we're being unethical in a class, right? So there's going to be some challenges at a very base level in school, and those challenges will extend to job as well. So, suddenly you have data, you have medical data, you have political data, or sensitive identification data. We have a lot of power and control over that data, and also the protection of that data, right? So we are the ones building the security systems. We're helping build interfaces to access information, and every student who's going to come out of UT is going to potentially have a lot of power and control over that, and we need to be very responsible in how we use that.
Sarah, one of the things that was listed on your bio that I noticed was the term non-photorealistic rendering. And I love that term. I would love for you to explain that more to our students.
Yeah, for sure. So, I mean, first of all, rendering is when we take an image and put it onto the computer screen. So we often think about games as being rendered images, but even this screen is rendering out pixels. It's just choosing which color of pixel to use. And generally, the way we think about rendering is photorealistic, i.e., we want it to look as realistic as possible. So if you've played like a AAA title in games, that's basically the high-end game titles. They're trying to make it look as close to reality so that you'd look at it and say, oh, that's a real actor, that's a real place. And the way we do that is with lighting models. So we're trying to make the light look as accurate as possible. In non-photorealistic rendering, we're doing the exact same thing, but instead of trying to make it look as realistic as possible, we're trying to stylize it. So there are many examples of this. I mean, probably the most accessible, easy one would be like a Mario game. You're never going to mistake Mario for a real person, but he has a lot of character. Or if you want a lot of drama, for those of you who are familiar with Breath of the Wild in the Zelda franchise, it's used as what's called cell shading. So you never think Link or Zelda are real people, but they look incredibly good and illustrative, and they can convey a lot of emotion that way. So the whole point of what's called NPR, or non-photorealistic rendering, is to not only think about like how do I make lighting models to make it look sort of stylistic, like an illustration or a watercolor or something like that, you're also sort of thinking about the psychology of like, how do I make people connect to this, or how do I make something scary, or how do I make something fun, or how do I make something dramatic. So I've always been sort of attracted to the interdisciplinary aspect of computer science, where we're not just working with computers writing code, we're actually thinking about like, how can I work with artists? How can I work with psychologists? And I think that's also a really fun thing about being in the university space, is you just have access to those people and connections that you might not make if you were sort of at a more typical software engineering job.
Right. Are some of the papers that you have published address this subject too of non-photorealistic rendering?
Rendering, yeah.
Get that one out.
Yeah.
You published some papers in tandem with some other professors and lecturers, I suppose, at UT. What was that experience like? What do you have to do to publish a paper?
It's more complicated than you might think. I mean, you've done the research, so you do the work that we would maybe think of as like the research work, making programs, testing it out, and then you just have to write a paper. And I will say the way I have to write a paper is probably more involved than a lot of students necessarily want to spend on their papers. Like, I can't do it overnight, certainly. There's a lot of editing. There's a peer review process where I send the paper in. They say, I like these things, but we want you to fix these things. So it's a very ongoing process, but it's very rewarding too, and it's something I'd like to continue to do even as a lecturer. I'd like to continue to being in the publication space. It's very rewarding to sort of see your work put out there and acknowledged, and it's kind of interesting. You actually will get people contacting you asking for access to your software, access to like, what are you going to be doing next in this, that kind of thing.
Sure. And some of the papers that you published, I noticed, were with other UTCS faculty.
Yes.
Are you also publishing with people outside of the CS department?
Not yet. I would like to, especially in the psychology. I'd like to do some collaboration there. It's a little challenging because the CS. It turns out in the world of publication, there's like CS journals and conferences, and there's psychology journals and conferences, and sort of finding a space where both meet and both sides really care about a particular interdisciplinary thing are going to be a different space from those things. But yeah, that would definitely be of interest to me. I am very fortunate to be part of a really great group called the High Performance and Parallel Computing Group at UT Austin. So I get a chance to work with research professors as well. And so I get a chance to not only sort of see what I want to do with students and kind of what do we need to be working with students. I also get to see what the latest in research is. Like, for example, the big graphics conference, so like what's coming out of SIGGRAPH. What are we doing with these things? So it's very exciting to be sort of able to do both sides of that.
One of the other things that you've worked on over these last few years, at least, if not more, is working at the summer camps. You've been providing your time for workshops with the students, and we've had a number of different formats. Can you talk some about those workshops and what you thought worked best so far?
So I'm very sad that I don't get to work with the students this year. This was it's a pandemic. What do you do? But I think we're gonna have some cool stuff that hopefully will be accessible to students going forward at some point. I mean, I love workshops personally. I like working directly with students. I like seeing their ideas and sort of helping them do new things with this. And I've done a couple different workshops. One was sort of a brainstorming workshop, just sort of like let's talk about how you make a game from nothing to something. So like, how do you come up with an idea? How do you come up with mechanics? How do you come up with who's on the team and what you need? And then we've also done workshops that are more like, okay, here's some pre-built code, now build a game on top of this. I think that's super fun. I would definitely need to spend more time building out the systems and helping sort of make a structured environment. But it's always really cool because I think you give students code, and then students come up with amazing things with very little direction, in my experience. So it's always great working with the different summer camps because the students are just so creative and so motivated. Um, and one day I hope to see all of y'all's code and see what y'all create, even if it's remote at some point.
If some of the people participating in our Summer Academy were interested in doing some things on their own this summer, do you have any advice for them?
Yeah, in terms of if you are interested in games, and depending on sort of how much computer science you've already taken, Unity is definitely a great starting point. That uses a language called C#. It's pretty easy to pick up. It's a big system, so it's a little bit more complex. If you're maybe like, I don't want to jump into something quite that large, I was using Phaser, which is JavaScript, and it's online. And that's a way to kind of like have a little less code set up. But I think both of those are great starting points. If you're just kind of like, I want to make a game, I don't, I know something about how to make a game, but I need a little bit of structure. If you have a lot of experience and you're like, you've taken a lot of CS classes and you feel pretty good and confident in yourself, you might want to check out Unreal. But I will warn you that Unreal is a very, very big engine, so that's kind of a step up. But you can honestly make really great games in Unity and even web-based programs like Phaser. So there's just a lot of different levels that you can kind of jump in at and sort of experiment with.
I think that some of the high schools are starting to offer a little bit more as far as CS electives and such, and game design is coming or moving into the high schools. Have you seen any evidence of that at this point?
Oh yeah, I mean, I think our students are incredibly strong at UT Austin, and they get stronger every year. And so yeah, I think we're just sort of seeing the accessibility of computer science. And that is not to say that you need to come in with computer science. So, I am particularly sensitive to this because I literally took no computer science until college. It wasn't of a particular interest to me. It wasn't on my radar. I was a very outdoorsy person. I was like, I just want to have a job where I'm out in the field working. Now here I am sitting in a desk all day. But so I didn't really take computer science classes, and it turns out that can feel a little bit hard, especially the first year when you're like competing against people, and it's not a competition, but it sort of feels like a competition, and your peers are like picking things up or have seen things, and it seems like they're going faster. But it turns out in about 5 years it all evens out. So once you graduate, 5 years, the person that knew more knows about the same as you do. You've caught up. So even if you are not taking CS classes yet and you're kind of like, am I interested? It's not too late. You can start now. You can start later. It's totally fine.
Sarah, we all love CS and we all love what we do. But outside of the computer science world, outside of all of this development that you're doing and paper writing and such, what else do you do for your personal enjoyment?
So this is actually pretty exciting time because my partner and I just got bees, like actual bees that live in hives and make honey. So we've been kind of learning about bee tending and beekeeping, and it's been like a lot of fun to be working outside because again, as I mentioned before, I love being outside. I love working with nature. So it's been really interesting watching bees and sort of learning about how to build hives. Obviously, students can't necessarily have a hive, but one of the actual cool things is, so the bees that I have are European honeybees. I should say we. My husband is actually the primary learner of bee facts via YouTube and books. But we have European honeybees, there's a lot of native bees, and you can buy bee houses for things like carpenter bees and mason bees. And so if you are interested and you have a little bit of yard space, you can put out these specialized boxes and help the native bees. So that's kind of my environmental message, telling you to you can do a part in a very small way right now. So that's what I think an interesting thing to share about myself.
No, that's fascinating. And I know some other people that are trying to raise some bees in their backyard, and they have gone the route of hiring someone to help them get it set up.
Yes.
And so I wish you the most luck with your bees, because they're struggling a little bit with theirs, and it's, you know, a real up and down situation,
Yeah.
but it's wonderful to see, and the honey is delicious. All right, Sarah, it's really been nice talking to you today. I wish you the best with all your coursework and taking that online. I know it's an interesting time for us. I hope you have a good summer, and I hope the bees bring you lots of honey in the future. And again, thank you so much for your time today.
Yes, well, thank you so much for having me.
All right, we look forward to having in-person camps with you next summer.